Okay, then, let's get started. So today we're going to talk about continuous testing in dotCover 10 and ReSharper Ultimate. So dotCover is now a part of ReSharper Ultimate. If you want to get a hold of it, you need to use it as part of the package there. And the idea for continuous testing is really kind of, it follows pretty much what the name says. It's about running your tests as frequently as possible. It's about making our red-green refactor cycle quicker, making the feedback between writing code and passing tests quicker. So hopefully we're all familiar with the idea of a red-green refactor cycle. The idea is you first of all write a test and write some stub code to get everything compiling. You build, you run the test, and you get a failing test. We've got our red test there. We've got an error we need to build. We then move on to green. We fix the code up. We build again, and we run the test again, and hopefully now we get a passing test. So we've written a test, and we've written a code to make the test pass. And finally, we get to the refactor stage, where we actually make the code nice. We clean everything up. We re-implement it properly. We get it working nicely. We build again. We run again, and at the end of this, we get a passing test, and we loop through and we go for it again. Now, this is obviously the way we do things for TDD. For test-driven development, that is. If you're not doing test-driven development, the principles are still pretty much the same. You want to write a test. You want to make sure that that test fails, first of all. Build, run your tests. You need to make things work. Build and run your tests. You need to refactor, make things clean. Build and run your tests. And of course, there's a lot of duplication going there. That's the build and the running of the tests. So continuous testing in ReSharper and dotCover is all about automating this build and running test phase to make it a lot easier for you to concentrate on just the things you're trying to do. So a red-green refactor cycle now hopefully just becomes writing the test and writing the stub. ReSharper automatically runs the tests. You write the code, ReSharper automatically runs the tests. You refactor everything, make it clean, and again, ReSharper runs the tests, and then you carry on and you write the next bit of functionality. So the idea is just to automate things to try and pull some work away from you and get you into this cycle and get the feedback going a whole lot quicker. Right, so let's start by actually having a look at some things there. We're going to have a quick look really at what goes on with testing in ReSharper. I'm just going to have a look at how tests work and the unit test support in ReSharper, and sort of point out a few things which you might not have spotted before. Some of this you'll be familiar with. Hopefully we'll get a few tips along the way. So I've got my demo project here. It's a mono.cecil. It's a real-life project, which is a very nice project, very useful for doing tests. It's a good size to show in demos. And I've got a test class here. It's an NUnit class. It's marked with text test fixture, and I've got methods then which have got the test attribute. ReSharper analyzes the code, and it can pull out in the editor where you've got a test, and it puts these little icons in the gutter here to show you that we've got a test fixture and a test, and if you click on those you get the options which we can use for those tests. We can also hit alt+Enter on the test fixture itself or on the test class, and we get these options here as well. We can run and debug and so on from here. And so if I just alt+Enter and I can just run my tests, let's make that a bit more visible. Then we get our unit test session window open. This shows us all the tests that we're running in a particular session, and in fact we can have multiple sessions. If I select a bunch of tests there, I can right click and I can say create new session, and now I've got two tabs and I can have two sessions running at the same time. And so I can do things like locking a session as well, so that nobody else can. I can't add anything to this or remove it. I've got a session which is just a specific piece of work that shows the specific tests for a piece of work that I'm currently implementing. And I've got my buttons here to run everything and to rerun my tests and cover and debug as well, so I can debug straight from here. There's also a useful button here which allows us to repeat the previous test run. So it's very easy to do rerun a session very quickly from the command line. Sorry, not from the command line, from the keyboard. Other useful things in here which are very helpful are the buttons along the top here, which are filters. So I can filter down to show me all tests, just my passing tests, failing tests, ignored tests, and then tests which haven't yet been run. So tests with an unknown result. And so I can show it there. I can also use the search field here to then filter down my test to just show things that I'm particularly interested in, and then perhaps I can right-click on that and debug or bring it into a new session and make it all useful there. A couple of other useful buttons we have at the top of the screen here. We've got one here which is to track the running tests. So if you've got running through a whole load of tests, we can click track running test, and the selected test will just follow the currently selected one. This is useful if you've got a filter already applied, and as you're running the test, we track the currently running one, and all the ones which don't match the filter disappear. So it's nice to show when we've got a failing test. So for example, let's make a failing test here. And we can use the keyboard to quickly rerun those tests. And we show now that we're just all of our failing tests here. When we're running those, if they're taking a longer time to run, we can click track running tests, and it will follow those as we go through. Useful things here, the output and the move that to the bottom or the right of the window. What we've got in here is a nice clickable stack trace. And so if I click on there, it'll take me directly to where my error is, or I can just walk up and down the stack trace and it'll navigate around, which is very useful. We've also got, this is another thing we've recently added, a show stack trace button in here. So if you click that, we actually open the stack trace. Again, a bit constrained for space there. We open the stack trace in a new window, and again, which is fully clickable, and I can navigate around just by clicking on the links there. It'll also allow me to click in the types and the namespaces here, and allow me to navigate around my code with this. It'll even allow me to sort of click through into the exceptions, and I can find the particular targets. This solution is referencing MS-Corlib in 2 different versions, and it'll take me there and it'll show me a decompiled version, which is very useful. And we've also got a button at the end here which allows us to reference .memory_unit framework. So .memory_unit is a NuGet package which is part of the .memory product, which allows us to do memory testing, which is again very useful, but not what we're here to talk about. So we'll move on from that. The things I want to show you is in the options pane here. We've got a lot of useful things here. Firstly, we can change how we're grouping things as they're displayed. But we can also select what platform and what framework we're targeting. This normally comes from the project, the project settings. So if we've got a C# project that is targeting .NET 2, then it will automatically run a .NET 2. Otherwise, it'll pick up whatever's there. So if it's targeting .NET 4.5, it'll automatically run with .NET 4.5 and so on. Similarly with the platform, we can say whether we want it to be 32-bit or 64-bit. By default, automatic is selected, and that's usually the one you want to have, but occasionally you will need to change that and set it to something specific there. It's a very useful little tip to know. We can also show the time, how long it takes to run a particular session, and it gives you the times there for all the tests, which is useful. Lock session is the same as the pin at the top of the tab. And then finally, this is the one I really want to show you now. There's the build policy. So this is what happens when we run tests. ReSharper will make sure that the project is up to date depending on this build policy. So automatic is the default, and automatic will make sure that the code is compiled and built before it will run tests. There's another option here which is automatic whole solution. So by default, automatic will only build the current projects that are required to run the tests. So in this example here, if I just bring up Solution Explorer again, I'm running tests from mono.cecil.tests, which is this project here. The only project this one relies upon is mono.cecil. And so when ReSharper is going to run those tests, it'll only make sure that those 2 projects are up to date. It doesn't bother about any others. So this is to try and speed up the time it takes for a test to be ready to run. You can change this here as well, so you can do the whole solution, or you can say always build, just make sure everything is up to date. So never sort of try and second guess things, always fire off a build, or never build. So you have to do an explicit build beforehand before running the tests. So one thing which is very useful then, one thing which we can do already without having to use anything like continuous testing, is if we make a change in code, let's go back to, oh, no, wrong button. So if I get back to my code here that I want to change, if I just do Control-T, then I'm going to rerun all of my tests, and now they're all running again. So, and ReSharper has built everything in advance. So this is already helping with the idea of quick feedback there. I just use a different keyboard shortcut. Instead of doing a build and then run, I just say run. my tests, and everything builds all up front for me, and everything's okay. So what is continuous testing for? What do we need continuous testing for? Is to give you optimizations, to optimize this process, to make it even quicker. So instead of having to build everything and run all these tests, it's managing a whole load of things for you. So I said at the start then that continuous testing is a part of dotCover, and ships as part of dotCover in dotCover 10. And so the question is, why is it use dotCover? What's so important about dotCover? And of course, dotCover gives us code coverage. And if we just have a quick look at that, we can alt+Enter here, and we can say cover all. We select that, and ReSharper will start to run tests with code coverage. And it analyzes the code as it is running, and it'll show us then at the end the coverage that we've got for this particular project based on the tests. In fact, let's switch over to a slightly easier test solution for this. This is a smaller app. This is a simpler application here. It's got a small temperature calculator which converts between Fahrenheit and Celsius, and it's got an implementation of quicksort, which we're going to write tests for. So if I just run those tests, what I can do now is I can run the test with code coverage, and we get sort of slightly more meaningful results here. Running that small number of tests on the monocessal project gives us a very small view of the code coverage there, whereas this gives us kind of a more interesting view of what's going on. So we can see in the code coverage pane down here that we have a very good coverage with our tests because we're running all of our tests. And so it's nice. So we can see that these two tests are 100% covered, and this one itself is actually not fully covered because it's actually throwing an exception. So we've got an expected exception attribute there. So not every line in the code in the test is being tested, is being executed, so it sees that and it marks that as not quite 100% coverage. And what we can do as well is we can have a look at the actual the implementation code as well. We can see that the util class is 100% covered, but the data class has some areas which aren't being covered as well. And if we double click through, we can see that highlighted on the code as well. So we've got green code here to show that we have actually been executed, and we've got red highlighted code here to show that this code isn't being covered. And in fact, if we just swap over, and no, that's the debug button. If we run that one, we will hopefully get updated code coverage, and we get higher code coverage percentage there as well. So code coverage is quite often a binary view. So what I've shown you so far, it's a binary view. We're saying that this code is either covered or it's not covered. But code coverage can give us a lot more sort of useful information here. So we can actually, if we're collecting the information nicely, we can do more interesting things with it. One example here is the hotspots view that we've got here. And if we click this here, what we see is a calculation of particular classes and methods where dotCover will calculate the cyclomatic complexity of some code and also mix in the code coverage and decide whether or not this code should be looked at to see whether you need to do some maintenance on it. So, for example, here we've got sample program, which it's got a low cyclomatic complexity. It's only got a value of 2, but the coverage is 0%. So if we click through here, we can see it's all red, and it's not terribly well covered right now. And so it's something we need to look at. So we kind of got this tag cloud down the bottom here, which is showing us that sample program is something we need to look at. Quicksort, on the other hand, has coverage of 100%, but the cyclomatic complexity is quite high. So it's saying that even though we're nicely covered, the code is still quite difficult to maintain. And we should probably have a look at that and see what's useful. So we want to try and use some of this code coverage data to give us more information. Another thing we can do, if we go back to something which is actually covered, is we can use the code coverage information to give us a reverse lookup. So one thing we can do here is if we hit alt+Enter and type in covering, we can say show the covering tests. And dotCover will now give us a list of all the tests which are which execute this bit of code. And so if we run these tests, we know that these tests will hit this covered line. And this is then very useful for, this is where we can use, where continuous testing comes in. Because we've now got the information to say that this particular line is covered by these particular tests. Therefore, if I change this line, I now need to rerun those tests. And so that's what we need to do. That's what we want to do. So right, let's go and have a look at continuous testing. So right, I'm going to enable it now in this sample project. We'll have a look at it a little bit further. To enable continuous testing, you can go to the ReSharper menu and click the continuous testing session here. You can also execute it down at the bottom. If I just zoom in down the bottom here, we've got a little icon here, not the red exclamation mark, which is showing me that there's been an exception, or the green mark here for solution-wide analysis. This one in the middle here is our continuous testing session icon, status icon, and that'll show us there. So I can double-click this, and we get a new continuous testing session window here. By default, continuous testing is disabled, and we can enable it just by simply selecting one of the different modes we've got here. So we've got several different modes, and this kind of changes the way that how continuous testing works. And the idea is that it's all about detecting and running dirty tests. The whole idea of a dirty test is essentially a test that needs to be run again. So a dirty test will include a test that has been impacted by a change in your code. So if I change the getter to Fahrenheit, for example, all those tests which I showed just a minute ago, all those would have to be rerun, and so they'd show up as dirty tests. And this is the modes here now really change the way that continuous testing either detects or runs those tests. So we can do it when we hit save or when we hit build, or we can actually say, no, I actually want to do an explicit command to both detect and run. So the standard mode that you really want to have is this first one here, unsave, build and run dirty tests. So when I select that, dotCover and ReSharper will say, well, do you want to run those tests now? So I'll just say yes. And so it'll go through and it'll run all my tests here. So we've got all the tests listed here. Let's just collapse those down. And it's just run through them and everything is fine. Now we've got another set of filters across the top here, like we have with the standard unit testing session view. And we can show our in-scope tests and our out-of-scope tests, and I'll cover this a little bit in a wee while. But we've also got filters then for passed tests or failing tests or ignored tests, and finally for dirty tests. So this will show us then the tests that need to be run. So if I go back now to my Fahrenheit getter class, if I then add in some code here, we will now see that dotCover has immediately picked up that there has been a change to my code. It's seen that I've changed a particular method or property, and it now knows that those tests that were referencing it have to be rebuilt. They're now dirty tests. They're listed in my sort of dirty menu there. And now if I hit the save button, ReSharper will rebuild my tests. Ignore the exceptions that we're getting here. I'm running the 10.02 EAP build. And an EAP build always has exception reporting enabled, so we can still see those down at the bottom flashing up. But it is seen that we've rerun our tests, and it has told us that we've now got errors. So our code is wrong. The calculation that we've got isn't working correctly. Now, we were still showing the highlights here. The highlights show that it's green. The highlights that we're showing for continuous testing are still code coverage test highlighting, rather than sort of highlighting to tell you the status of the test or to show you that this particular line is failing. Highlighting is something that we're going to be focusing on in one of the next versions. But for now, we've kind of got the code coverage and the continuous testing itself built. So we can disable that simply by going to the cover menu and clicking disable code highlighting. And so we've now got our failing tests on the right hand side here in the continuous testing sessions window. We've got our stack trace. There's no one if I sort of let me just grab that, pull that out a bit, and then there's my line which I can click on, and that'll take me to the error where it's asserting everything. And where are we? So that's testing that implementation there. And so then if I edit that again, we see now that our tests have disappeared from that list, and they're now back in our list of dirty tests. And again, as soon as I hit save, ReSharper will build and run those tests for us. So we've got a number of other options across the top of the user interface here. We've got a button there to explicitly run dirty tests. So if you're not having it run automatically, if you're not automating the process, then you can just click the button and have it to run. We've got another button which will run all of our shown tests. So if I've got all my passing tests there, I can click the run all shown tests, and it'll just quickly rerun them for me. We've got a stop button here as well, which will stop our tests and abort everything. And we have a drop results button as well. So if you want to turn continuous testing off, you can drop the results, or you can turn continuous testing off, and we're all done. Okay, so let's switch over to a different solution then, and then we can sort of see then how it would actually work with, so if we're doing some sort of test-driven development. So if we do if we're going to create a new class now, so we'll do some new tests to just sort of check a simple thing like a calculator. So let's create calculator, not that one, .add. We can create a new type, add a new method. I can build that, and right now, if we look down the bottom right-hand side, we've got a green icon there to tell us that our code is all clean, but we haven't yet enabled continuous testing. So let's just turn that on. We can run the test now. We've got green code, so we've got we're doing a red-green refactor. Let's just show all code, all tests there, and we now see that we've got a red test and we've got a failing test there. Because we haven't got an implementation, so we can just simply change that to give us a nice implementation. Hit save. The tests are the code is rebuilt and rerun, and we've got a passing test again. We can simply sort of then add a triangulating test to make sure that we're not cheating in our code. We've got some red again, so let's do a proper implementation, and hit save, and it's running and it's testing, and we're now quickly getting through our tests. We can implement them quickly, run them quickly, and see where things are failing, see where things are going green. If we want to add in another test, incidentally, this is a very useful plugin called XenSharp, which is a really nice way of quickly adding in snippets of code. So you can add in things like a method. You can create methods very quickly, public method very quickly like that, or properties, and also test methods. So you can just type test and put in a name for it and hit tab, and it'll expand that out for you. Very useful little plugin for writing code quickly. And we can do a similar thing then to add in some new code. Calculator .subtract, and let's do 43 and 1. Okay, and so now immediately if we have a look on the right-hand side, our dirty test has now pulled up test subtract, which has already run apparently. I know that's there. So if we implement that and save, that should rerun. And okay, there we go. That's more like it. Gives us our not implemented exception. So it already picked up the test that we added, automatically as a dirty test, and it has it ready to run. And again, we can just sort of return something quickly, save it, and it would implement it. While that's running, we could be writing another test. Let's just change that to that, save that, and it will show us that we're failing, and so then we can just write a simple implementation, save it and build it, and we're good to go again. So we do, so ReSharper and dotCover does change detection of your code as you're typing and as you're writing. So right now, if I'm in the add method, we can see that I actually changed the add method there, and we immediately see that ReSharper has picked up that the add method changed, where we are, and see that it's failed, and immediately flags it up as a dirty method. So it gets listed as dirty methods, and then it's run, and then it's all goes through quite quickly. Okay, so What we've also got down here as well is the code coverage tab. So if you want to see what's going on with code coverage in your code from the continuous testing session, you can still see the code coverage here. We've got the coverage tree or the hotspots view. We can show the coverage just for the selected test. So if you just want to select, say, the subtract button, and then say have the show me the code coverage for just subtract, it'll filter out the coverage for that one. There's another button here which is matching the coverage results for the current project structure. This is useful if you have references as well. So if you're including other DLLs and other assemblies into your project, dotCover by default will include those into the code coverage, and those can get listed as assemblies here. And so you can say, actually just match it to the current project structure, and it will just show you the code coverage for the code within your project rather than per assembly. So here it's now showing me, it's changed the icon there to be an assembly, so it's showing me all the code from the CTCS assembly rather than here now it's showing me for the project. This is more useful when you've got a bigger project which is referencing more code. And again, you can enable the code highlighting from here as well, so you can get to see straight from this option, this view here, what is covered and what is not covered. Okay, so down the bottom here, down on the status bar, we've got our status indicator here telling us that we've got 2 failing tests. So if we can keep an eye on that window down there, that icon down there, that will allow us to see what's going on with our unit tests without having to have the continuous testing session window open. So we could close that down. We know we've got 2 failing tests, and if I just fix up my code now and save that, we can see that down the bottom here it's busy whirring away and rizzing, and we finally got a green tick now and everything's fine. If we just have 1 failing test there, it will show us down here. There we are, just 1 failing test. Okay, so where's our continuous testing window gone? Okay, the other useful thing to show here is the export button here, which we can use to export to the code coverage useful information to HTML, to JSON, to XML, to NDepend as well, so that we can import it in and view that information with a whole sort of dependency diagrams and stuff, as well as then for different XML formats to give us that information, which we can then use to transform into HTML pages and so on. Okay, so let's have a look then at let's have a look at this at work in a larger application here. So we're going to switch back to mstest. Let's just close the highlighting. And what we're going to do now is we're going to enable continuous testing. And what we're going to say is, I'm not going to run all my tests right now. So I'm not going to run my tests right now because I know that mstest has a number of tests which are functional tests, and they run slower than what I want. So continuous testing is really ideal for nice, quick unit tests. So when you have tests that can give you a very quick feedback cycle. If there's something that has to write things to disk or compile something or contact a database, for example, they're going to run slowly. So that's going to affect your feedback cycle anyway. So that might not be the place, the best use of something like continuous testing. Smaller unit testing, unit tests are going to run better. It's also a good chance to show you then what we mean by include and exclude scope. So we can get to say what tests that we want continuous testing to treat as being in scope. So I've got this this test class here, and I want to say, well, I'm just interested in what's happening with this test here. And so we've got, if we hit alt+Enter on here, we get our usual sort of menu of all the options we can do. We can run, debug, cover, and profile from here. But we've also got a couple of other options here. So we can say cover in a continuous integration, continuous testing session, or exclude from continuous testing. What I want to do is, actually what I want to do first of all, we've got our full solution in scope at the moment. I'm going to exclude from scope. So basically I'm saying now that none of the tests in the solution are to be included in continuous testing. So when I save now, it's not going to run anything. It's not going to run any of my tests because there's nothing for it to run. Everything is currently out of scope. So if I hit alt+Enter again now, I've now got the including continuous testing. So when I click on that, now it's giving me the tests that I can use and that are going to be considered to be in scope. And when I hit save, ReSharper and dotCover will actually execute those tests and run them for me. So this is useful for when I just want to run a handful of tests. So for example, if I make a change in the class that those particular tests are testing, then I can run it just on those particular tests. If on the other hand I include everything in scope, so I've now got all of my tests, all my 200 odd tests in scope, and if I make a change here, well, I've now actually got a lot of tests that are affected by this change. And while it is very, very useful to have to run all of those tests, there are times when I don't necessarily want to, especially if those tests are going to be more heavyweight and running more than I want them to do. So I'm going to let's just do that again. Exclude from scope. Switch back to the type parser one, and just include these. If I go back to this code, and I can run that, it'll just run a handful of tests. Okay, so that's including and excluding scope, so I can sort of reduce the number of tests I run and exclude tests that I don't particularly I don't need to run just now because they're too heavyweight. There's an extra feature in ReSharper 10 which really plays nicely with continuous testing, and that is ReSharper Build, which we're going to have a quick look at now. Let's just get back to the line we are. So ReSharper Build is a new feature in ReSharper 10 which is designed to speed up the building of your solution. It doesn't speed up the building of your projects, but it speed up the building of your solution. And it does this by intelligently skipping projects that don't need to be built. So for example, if I have a utility project that is used by every other project in the solution, normally when I change that utility project, Visual Studio will rebuild everything that references it, even if the change is just something to an implementation. If it's an implementation detail, so the API itself hasn't changed, Visual Studio will still recompile everything else. ReSharper Build is smart enough to know that an internal change makes no difference. You don't have to recompile everything in order to get in order to be up to date with that build process. So it optimizes the build. It skips projects that don't need building. And so there are kind of three things really that it does to try and speed things up. First of all, everything is run completely out of process. Visual Studio still hosts various parts of the build system in process, and so we've tried to push it out of process so that we can reduce memory pressure and performance pressure out of process, and have that running in a separate process to try and increase things. And then it also does efficient timestamp monitoring. So part of the out of process build will keep an eye on everything that has changed. ReSharper Build will keep a track of all the inputs and outputs to all of your targets, and if anything, it'll keep a track then of when anything changes. It maintains a dependency graph of all of these changes, and as soon as it sees that something has changed, it can invalidate that dependency graph, and it knows that a project needs to be built. And it finally does this public API monitoring. And the idea of that is if you change something which is an implementation detail, you don't have to recompile everything. So we're trying to reduce the number of things that gets built when you need to build something. And this is very, very useful then for testing. Because if you have an assembly you're trying to test and an assembly which contains the tests, when you change the production code, you don't have to rebuild the test code itself, so you can immediately reduce the number of things you get to build. So I'll just show you this in action. So ReSharper Build is disabled by default because it doesn't work nicely with pre and post build custom build steps. If you have a custom build step, then you don't get to say anything about inputs and outputs, and we can't do timestamp monitoring on that, and so we don't know when things need to be run. So if you have a custom build step, we can't run with that, and custom build steps are a bit of a black box, and so to guard against that and to make sure that your builds work by default, ReSharper Build is disabled by default. But you really want to sort of enable it to make use of this. And the way you can enable it there is to go to ReSharper, Windows, Build and Run, and we get a new tool window here, and we get a little hyperlink down here to tell us that firstly the Visual Studio's build is currently being used, and a link to enable ReSharper Build. So once we enable that, then we get a little box here which shows us the status of every project in the solution. And now if I just do a build, ReSharper Build is going to go off and rebuild the things that need to be rebuilt, which currently is just the mono.cecil project and the mono.cecil tests. All of these other light blue projects don't need to be rebuilt. If I just do rebuild now, you can see immediately that nothing needed to be built. So the number of times now, if I do a build, nothing's happening. It's very, very quick, and it's very fast at spotting that things don't need to change. So now if I want to use this with continuous testing, for example, if I make a change in a actually, let me just show you something else first. So what we can see here is this particular class is an internal class. Let's make it a public class and just rebuild. Oh, let's rebuild twice. Are we up to date? Let's just check. Okay, everything's up to date. So everything is built. Everything is skipped now, so it's not being built. If I add a public method, and build again now, I've changed the public API of my assembly, and everything has to be built. You can see here everything is green or yellow as appropriate. Now let's just change that back to being an internal class. And again, I've changed the public API of my class, so it's rebuilding everything. Let's just make sure everything is fully up to date. Okay, now if I change my public API now, and if I rebuild, then ReSharper Build knows that only implementation detail has changed. And so it rebuilds mono.cecil, but it doesn't rebuild anything else. It doesn't even rebuild the test project. If I add in a comment, hello world, if I add in a new comment up here, and if I rebuild that, then again, ReSharper Build knows that the public API hasn't changed, and so it only rebuilds the one project. So let's get back to my actual line here. If I comment out this line here, then ReSharper Build will know that the public API hasn't changed, and it should now be able to rebuild everything really quickly. And it does. It just shows us that only one method has changed, and in fact, we have already rebuilt our tests, and they're all passing. And if I do that and save, just rebuilds one assembly, and my tests are now immediately failing and not showing up in the list. Interesting, they're not showing up, but they are now. You can see that the count there is all. That's why they're not showing up. They're there, but they're hidden by the preview pane. So we can see now that ReSharper Build makes it very quick to rebuild and rerun your tests there. So what you want to do is really use the two of them in conjunction. Have your continuous testing session enabled, and also use ReSharper Build, and ReSharper will optimize your build and rerun just the tests that need to be rerun. Okay, finally then, last thing I want to show you, if no, I just need to fire up a thing there, is continuous testing supports, it supports NUnit, xunit, mstest, and everything all works nicely for that. So let me just load this up. So you don't have to do anything. As long as the xunit plugin is installed, then it will just work. And here's one I almost prepared earlier. It would have been better to have this up and running, but there we go. And of course, it's all going very slowly because I'm trying to show it to somebody. Okay. Come on. There we go. Okay, so we've got NUnit code here, and so if I make a change to that and save, then all my tests should get rerun. Built. They don't want to. Okay, this is not going nicely. Let's try all this again. So if you could just bear with me for a sec, we'll just try that one again. All right, let's just run all my dirty tests. Is that going to run? No, I think I've been bitten by the demo gods here, which is unfortunate. I wanted to show you here that we support NUnit, xunit, and mstest, and also the change detection we use. So when you are making an edit to your code, and we immediately see that it's a dirty test. So the idea then that we see that if we make a change there, and we see then we've got changes in our dirty tests there. We have two modes of discovery for that. So firstly, for file types that we understand, such as C# and VB, we know immediately, based on ReSharper's deep knowledge of the code, of the structure of the code, that this particular method has changed, and this particular method it impacts these tests, and these tests are therefore now dirty. But on top of that, we also have a metadata based a file checker, which will check the compiled assemblies. So if you have code which is external to your solution, so generated code perhaps, or code that we don't natively support with ReSharper, such as F#, then we can still notice that these particular tests are impacted by changes to this code. So we can actually support F# as part of this as well. So we support any .NET language, providing it builds us a compiled assembly at the end, because we can examine that compiled assembly, see when any of the methods have changed, and because we can do code coverage based on the .NET assembly, we can then work backwards to do a reverse lookup to find out what tests have been affected and impacted. So it's unfortunate that test didn't work. I apologize. Okay, so let's just finish off then. Some hints and tips really. Useful things to know is that when you run your tests in continuous testing, everything is shadow copied. So if your code has issues with shadow copying, then it might not play nicely with ReSharper Build. So you want to avoid putting in specific file paths in your code. You can get things copied. Shadow copy will .NET will automatically copy appropriate files through for you. If you do anything outside of that which isn't supported by shadow copy, then obviously that can't get supported by continuous testing either. Other useful things is you probably want to avoid running long-running tests. You probably want to favor unit tests for this. Have small, quick-running tests, because the whole idea is to sort of speed up the feedback cycle. So you want to have things which are going to work with that fast feedback cycle. You don't want to be really quick to run off long-running tests. You want to avoid dependencies between tests. So if any of your tests are based on have to run in a specific order, then this isn't necessarily going to work very well with continuous testing, because continuous testing will not necessarily run all of the tests in a particular class. So if a test isn't impacted by a change of code you made, then you can run things in a different order to if you ran just the whole test itself. Use ReSharper Build. There's a very, very useful tip. ReSharper Build is very good at speeding up building of your solution, reducing the time it takes to build multiple projects by skipping them and only building them if they really need to be built. And finally then, continuous testing does not support legacy mstest, which is the .test settings, I believe it is. It doesn't support Silverlight or WinRT tests either. Okay, so that's pretty much everything I want to show you today. Just have a quick look at some of the questions. We've had some questions in which have been answered. Let's just see if there's anything worth picking out. So one of the questions we've had is about the code highlighting. So the code highlighting we're showing at the moment is whether or not code is covered or not covered. The question is, are we going to have something which gives us a different sort of information, such as whether a test is failing, whether the code is covered with a failing test or a passing test? And the answer is really that highlighting is something that we're going to be looking at in the next version of future versions and working on that for sure. The other questions we have then is the continuous testing sessions, are they saved in the ReSharper in the ReSharper .settings file, which lives next to your solution file? And the answer is yes. So if you want to sort of move files out of scope, you can then have that saved into your .settings file and shared across your team. And one final question coming in then, where does the profile all option come from? So when you do hit alt+Enter on a test, and it shows you the list of items. So if we just swap back and a method there, and we've got run all, debug all, cover all, and profile all. Profile all is from dotTrace, and that allows you to do a performance profiling of your tests. So cover all does standard dotCover code coverage, which will give us our code coverage values and our sort of hotspots values, and profile all will give us profile information. It'll launch dotTrace and allow us to see then how long a particular profile, how long a particular bit of code is taking to use. Okay. So then that's all that's left then really is to say that if you want more information, if you want to send any feedback, you can ping us on Twitter. I'm Citizen Matt on Twitter, or you can send things directly at ReSharper as well. If you want to send any emails, you can email me at matt.ellis@jetbrains.com. If you want to get ReSharper and ReSharper Ultimate, which includes dotCover, then go to jetbrains.com/.net. And finally, the recording will be available early next week. So the last thing to say really is thank you very much for watching, and the screencast will be available. We'll publish it to the blog, and it'll be available then on youtube.com/JetBrainsTV, where you can see other screencasts and webinars. Okay, thank you all for coming.